Hello everyone, my name is Kesritalk. I'm a student of VIT Bhopal. Today we will see what is grade. Okay. In this lecture, we will discuss about grade structure in operating system. Grade structure in operating system. I will try to explain this best of my knowledge. Okay. So let's start. RAID stands for redundant array of independent disks, or we can say redundant array of inexpensive disks. Here, redundant means copy. Okay, copy of what? Copy of disk. Copy of disk. Array. Array is a collection. You can say collection. Okay, of independent disk. Independent disk in the sense disks are independent of each other. If one disk fail, it will not affect other. And second thing which I said, independent array of inexpensive disk. Inexpensive disk. Here we are using inexpensive disk. Here we are using inexpensive disk. That's why we can also say redundant array of inexpensive disk. Inexpensive disk means if we talk about memory hierarchy, at the bottom, according to cost, hard disk will become now because it is cheap. So we can use hard disk in large amount because here we are using multiple disks to store data. Okay. So RAID is a redundant array of independent disks. Is a data visualization technology that combines multiple physical drive components into one another logical units for data redundancy, performance, and improvement of code. So why we are using RAID? Why we are using RAID? For performance. Performance means read and write operation. And redundancy. For redundancy, data redundancy means availability of data. Availability of data. Okay, if we will store data, copy of data on a multiple disk, we can retain it from anywhere. Even if data gets fail or any drives, sorry, if any drive gets fail, we can retain that data from another. So this is the advantage of using RAID. Okay, and in many companies, large companies, they are using RAID for better performance and availability. How RAID work? RAID work by placing data on a multiple disk. As I told you, we place data on a multiple disk. Okay. If we will place same data on a multiple disk, we can simultaneously use access the data from both disks. So this will definitely increase speed, performance. That is read and write operation, allowing input-output operation to overlap in a balanced way, improving performance. Okay. Here you can see balanced way. Balanced way means if we will take too many disks, then it can create problem. So copies should be in limited number. If we will make, if we will take too many disks, this will not good in a balanced way. We will use in such a way that it helps in improving performance because various this increase the mean time failure. See, okay, and storing data redundancy also increase fault tolerance. What is fault tolerance? Fault tolerance we can say if any error occur, even then operating system keep on working. Okay, so RAID array appear to the operating system as a single logical drive. RAID employs the technique of disk Mirroring and disk stripping. Okay, these are the two techniques: disk mirroring and disk stripping. In next slide, I will tell you in with example what is disk mirroring and disk stripping. But till now, you should remember that RAID employs the technique of disk mirroring and disk stripping. With this technique, RAID work. Okay. See, these are the level of RAIDs. Here are the many level of RAID. For example, RAID 0, RAID 1, 1 plus 0, nested RAID is also called nested RAID, RAID 2, RAID 3, RAID 4, RAID 5, RAID 6. These are the level of RAIDs. Okay, so let's start with RAID 0. So RAID 0 uses which technique? Stripping. Stripping. What is stripping? We are dividing data into two disks. We are dividing data into two disks. So what is the use of this? It will increase performance. How? If, for example, data is stored in two disks and someone want to access, so they can access from both disks or they can read from both disks. They can write from both the disks at the same time. So this will increase performance. This will definitely increase performance. So RAID 0 is used for performance. No redundancy of data. In this, in this, both disks, we are storing different data. Okay, and let's compare it with RAID 1, then you will see. In RAID 1, mirroring is there. It means that in both disks, you can also say disk or drive, both are same, no problem. So in both disks, we are storing the copy of same data, है ना? And in RAID 0, in both disks, different data is there. In RAID 1, copy of same data. So what is the purpose? If one disk fail, if one disk fail, you can retrieve data from another disk. This is the purpose of RAID 1, and this technique is known as mirroring. Put the copy of data into the different disks. Okay, and this helps in the availability, which means you can access data even when one disk fail. Now see what is RAID 1 plus 0. In many books you will see it is written as 10. Okay, so it's not a 10, it's 1 plus 0. It means it is the combination of RAID 1 and RAID 0. In this, you will see both technique, mirroring and stripping. See here, it's mirroring is there, mirroring is there. And if we take this, both, this is stripping. Mirroring in the sense in both drive, we are storing copy of same data into another drive. Okay, we are storing the copy of same data into another drive. But if we compare 1 and 2 and 3 and 4, data is divided. Data is divided. So this is called stripping. So it will provide the functionality of both RAID 1 and RAID 0. That is, availability is also there and security is also there. Performance will also be there. So in real life example, in real life application, mainly RAID 1 and 0 is used. Okay. Now let's see what further. RAID 3. RAID 3 we will first see. Firstly, we will see RAID 3. Hmm. Parity on a separate disk. RAID 2 is also there. In RAID RAID 2, byte level parity is there. It is not very important. So in RAID 3, block level parity is there, and we will see about RAID 3, right? So see, here disk 1 is there, where multiple data is there. Disk 2 is there, disk 3 is there, and disk 4 is the parity disk. Here we are storing the parity of different disks. We are storing the parity of different disks. See, here 1, 2, 3, and disk 4 is storing the parity of A from 1 to 3. Similarly, A5, A6, A6, and it is storing the parity from A to 6. So what is the purpose of parity? Here, if, see, uh, I explained this block level, store parity along with original data. You can see parity is there along with original data. If one disk fail, we can recover data. Okay. Purpose of parity is if one disk fail, you can store data. How you can store? See, for example, it is 1, 2, 3. Okay. And in parity, it will store this sum of all data. So 6 is there. And let's assume this data is lost or is not able to access. But with the help of parity, you can calculate or you can find this. How? We know this too. What is the sum? 5, right? So 6 parity we know minus 5 we get 1. 1 represent this now. See, we got the answer. In this way, parity helps us to recover the lost data. Parity disk cannot be accessed because of overuse. What is it mean? It means that here is the single parity. Every time for every data you have to access this only. So because of overuse, this rate fail. Because of overuse, this rate fail. So what is the solution of this? Rate 5 gives solution of problem which we are facing in rate 3 and 4. 4 is also like same. है ना? 4 is also giving solution, but more organized and more right is rate 5. In rate 5, we are storing parity in each disk. We are storing parity in each disk. So parity is distributed over all disks, so no disk is overutilized. You can see parity is distributed over all the disks, so no single disk is overutilized. This helps us to for better read and write. Read and write operation will be better. This is the last topic. RAID 6, right? RAID 6. RAID 6 is there. Try to understand. First, you try to understand what in RAID 6 is there. I am denoting, and you have to figure it out. Okay. Try to figure out. You will easily understand. P and Q are the parity. I am giving you a hint. P and Q are the parity. we have two parity for each data distribution over the disk. Even if two disks fail, we can recover data. Even if two disks fail, we can recover data. Similar to RAID 5. In RAID 5, we can recover data of only one disk. If one disk data of one disk fail, we can recover. But in RAID 6, if two uh, data of a disk fail, we can recover it because we have a two parity in each disk. Okay, that's all for today's lecture. Thank you. I hope you find this lecture useful. So let's once recap what we have learned in this lecture. So let's start with RAID. What is RAID? It is a visual. So what is RAID? RAID is a storage visualization technology that combine multiple physical disk drive component into one or more logical unit. जैसे आई हैव टोल्ड यू अर्लियर ऑल्सो कि रेट क्या है, एक स्टोरेज विजुअलाइजेशन टेक्नोलॉजी है जिसमें हम लोग मल्टीपल डिस्क रखते हैं। क्यों रखते हैं? जिससे कि हमारी परफॉर्मेंस इंक्रीज हो जाए। परफॉर्मेंस इन द सेंस रीड एंड राइट ऑपरेशन और डेटा रिडंडेंसी, कि मल्टीपल डेटा अगर एक ही जगह पे रहेगा तो अगर एक डेटा लॉस भी हो जाता है, एक डिस्क खराब हो जाती है, फिर भी वी कैन रिकवर डेटा फ्रॉम अनदर डिस्क। Okay, and then how did it work? In this, you have to remember this. There are the two type of techniques: mirroring and stripping. What is stripping and mirroring? Uh, you can explain this with example. In RAID, stripping is there, which means we divide data into two different disks. So how it is useful? Performance is increased because as data is divided into two parts, you can access both disks simultaneously. This will increase performance. Okay. Then in RAID 1, mirroring is there, in which same data is kept into two different disks. Okay. So if one disk fail, you can recover data. RAID 1 and 0, it is the combination of both RAID 1 and 0, which means in this mirroring and stripping both is included. And this is a real life example. Okay. Then RAID 3, it is a block level parity. Okay. And what is the use of parity? With the help of parity, we can recover data if one disk is failed. I have explained this with example also. Then in RAID 5, uh, you can see in RAID 3, there is a separate parity disk. Okay, and because of overuse, this can fail. But in RAID 5, parity is distributed all over the disk. So there is no load on one disk that it can be overutilized. Parity is distributed in all over the disk, so every disk is utilized evenly. And then in RAID 6, same same as the RAID 5, parity is distributed all over the disk, but there are two parity, two parities. So even if two disks fail, you can recover data.